Welcome back, everyone. So hopefully you managed to convert these components over to lazy loaded components and then render them with suspense wrapped around the actual two routes. It's pretty much the identically same code that we had in the app.js in our last lesson, except the only difference is we wrapped the routes itself, these route level components. Now, some of you might be wondering, what about wrapping the other components that are not page level components inside of a lazy import? Technically you can, but the benefits are not really there. Because if you think about it, the components that you end up rendering that are not at the page level are not as large. Like our header component, for example, is actually quite small, whereas the page component has a lot of different things on it that make it a full homepage component. The homepage component itself contains not only the homepage content, but the directory, and that in itself is another component set. The shop component contains multiple other components in the routes that technically in their own way deserve to actually be separated. So unless you actually see that there's a certain component you have that isn't a page level component but is really big and needs to be possibly asynchronously loaded because it's slowing down the overall rendering speed of your website, then you can actually do it. But again, you want to make sure that you actually see it first, that it's really slowing down in production. Now, of course, we haven't actually been testing this in production. We've only been testing this in our local. But we will do that later. Right now, it's perfectly fine for us just to see our chunking occur inside of our local development server. The other thing we do have to think about, though, before we push to production is that with chunking now, we are depending on our network being active and fast whenever we make requests to new routes. Because now, whenever the user navigates to a different route, such as our homepage or our shop or our checkout or our sign-in, we are fetching from the backend the JS chunk related to that route now. This means that if the connection suddenly stops or slows down and throws an error of some kind, we don't know, it could be any kind of issue related to network, well, we're not going to get anything back and our spinner is going to hang indefinitely. In fact, if an error comes back, we need some way to handle it because Suspense is not going to know what to do with that error and our app is going to break. The easiest way for us to do this is actually with something called an error boundary. Now, what is an error boundary? An error boundary is another feature that was introduced around the same time that React Suspense got introduced in 16.6. Error boundaries is essentially a way for us to write this unique component that will, very similar to Suspense, catch an error and then render some fallback component or UI instead of just letting that error occur the way that we've normally seen them occur, where the app breaks and then it takes us to that weird page where it tells us about our error. So what we want to do is actually write an error boundary. And this error boundary code is actually really easy to do. React will naturally know that we're writing an error boundary if we use one of two lifecycle methods, because an error boundary component is a class component that has either a component did catch lifecycle method in it or get derived state from error. Now, I'll actually show you what both of these are because they both serve different uses. But this component is actually really easy to reason about. Now, what we're going to do is we're going to make this new error boundary component, and we can call it whatever we want. In our case, let's just call it error boundary. Now, in this error boundary component, we are just going to create our error boundary dot component dot JSX. We're going to import React from React because we're pretty much just writing a component, and we're just going to literally declare an error boundary component like so. And this is going to be a class actually, because we're writing a class component because we need access to those lifecycle methods that I mentioned. So we'll say class error boundary extends React.component. Now, in order for React to know this is an error boundary component, we need to use either one or both of these lifecycle methods that are unique to error boundaries. Now, we do have access to them in any component that is a class component, but the moment we have it, it becomes an error boundary component. The first one is a static method known as getDerivedStateFromError. Now, inside of this first static lifecycle method, what this does is it essentially catches any error that gets thrown in any of the children of this error boundary component. So what we're going to do is take this error boundary component and wrap it around a bunch of components or a single component. And then whenever any of the children, so any of those wrapped components inside, get an error or throw an error, that error gets passed in as the parameter of getDerivedStateFromError inside of our error boundary component. Then what we can do is we can process the error somehow, right? We can do something with it. We can look at it. We don't even have to. But all we have to do to make sure is return from this method some object that will set the state inside of this class. Now, what do I mean by setting the state? Well, because it's a class component, we do have access, of course, to local state through the constructor, calling our super, and then setting this dot state. What we want to set is probably something like has errored, which is just a property that will yield a Boolean that lets us know whether or not the state has errored inside or has not errored. What we can do then is say that we want to return has errored goes to true. So just to go over quickly what we're doing with this error boundary class component, we're instantiating this class component just like any other class component. We're setting up our constructor, calling super, and then setting state to have some has errored value inside of local state to be true or false. This has errored state just lets us know whether or not any of the children inside of the error boundary has actually thrown an error. Now, in the static getDerivedStateFromError lifecycle method, this thing will actually get the literal error that was thrown if any children inside of this error boundary does throw an error. And then we have to make sure to return from this method an object representing the new state that we want to set locally. So we want to say has errored is true. And now the rest of the component is aware that this error has happened. The second lifecycle method we actually have access to that lets React know that this component is a error boundary component is componentDidCatch. Now, what componentDidCatch does is it gives us access to both the error and the info related to the error and how it got thrown. So info might be which component actually threw the error, like which component actually broke. And all you do here is really, maybe you want to log it, or maybe you want to send this information somewhere. It allows us to perform some side effects with the error itself. So for example, we can console log out the error for our own benefit so we can see it. That's all this method does. The most important one, though, is getDerivedStateFromError because we need to do this manual set this way. Otherwise, we're not aware of the children inside of this component actually throwing errors. That's the main thing. This method allows us to catch the error ahead of time when it gets thrown inside of any children nested in this error boundary component. And the reason we're going to do this is because in the actual render statement of this component that we're writing, we want to conditionally return different UI depending on whether or not the local state of has errored is true or false. So if this .state.has errored is true, then what we want to return might be a div that says something went wrong. Now, if this .state.has errored is false, then instead we will return this .props.children. So literally what we're doing is we're just waiting to see if an error has happened inside of the children of this component. If something happened, if an error gets thrown, we set local state, and in turn our render will then return a div that says something went wrong, or any UI we want here to represent our error state. Otherwise, just render the children normally. So if no error has occurred, then the children are just going to render as they always will. So what we'll do in order to actually use it is we will export it as the default as our error boundary component. And then we can just bring it into our app, for example. So let's just import in our new error boundary component from components. error boundary component. And let's get rid of those JSX. And then what we can do is now wrap our suspense inside of our error boundary. So now what's really great about this error boundary is that now if any of these ever break, so if any of our lazy loaded routes, for example, the network goes down, something goes wrong inside of actually rendering this component, then the error boundary will default to this fallback. The fallback being that component that we supplied as what gets returned when something has errored. Now, we can actually test this out. If we go into, say, our homepage component, and what we do is we modify this code to manually throw an error. So let's just say we throw error like this. If we now check our application, we see that what gets rendered instead is something went wrong. So this is really great for us because we never have to show our users that ugly error state at any point if we don't know what might happen. So similarly, in everything else that we've done, one of the big things to consider is that because this is being placed in our component tree and it does nest certain components of our choice, we have to think about the purpose of what we're using this error boundary for. So we can literally render different error boundaries and write multiple different error boundary components if we wanted to that do different things with the errors depending on where we place it. It's really just a tool that's for us to use. So that's one big important thing to remember with error boundary, but it's really just that. The error boundary code is really just a simple component that has access to these different lifecycle methods which allow us to do something with an error that gets thrown inside of any of the children. We simply set the state whenever an error occurs, and then conditionally render some specific UI based on whether or not an error has occurred or not. But let's render something a little more professional looking than just this div that says something went wrong. Instead, what we can render is actually a component that uses some image that is maybe a little bit cuter or at least a little bit more obvious that shows that we put a little bit of thought into it. So there's actually this great resource at this link that I will include for you as a resource that has a lot of images that kind of show you that there's something that went wrong with the page. Now I'm going to use this one, and it really just takes you to a URL that gives you the image itself. We of course have to supply the text, and I have created the styled components that you can bring into your error boundary component, and I will also give you the style components page and code in your resources as well. So what you'll do is you'll copy it and you will create a new error boundary.styles.jsx and just paste it in. Then what you got to do is bring in these three components: the error image overlay, the error image container, and the error image text from that styles. So in order to use them, instead of rendering out this div, what you're going to use is the error image overlay first. And this is just the container that holds it and centers the image and the text. This error image container simply takes a image URL string property, which you can supply with any of these images that you want. It's entirely up to you. I'm going to use this cup. So I'm just going to copy this in and paste this in here. And then as far as the image text goes, I'm just going to say, sorry, this page is broken. And now if we save, we go back to our application, we'll see that if an error occurs, instead they'll end up seeing this image, which I think looks way nicer. So again, this is just one example of what you can do with error boundaries. But it's really flexible and it's actually really easy to use. And now we can have our suspense and our lazy loaded components without having to worry if, say, something goes wrong, if our app goes down, or if our server goes down, or if an error gets thrown inside of these components due to not being able to fetch it. This error boundary component is able to catch and handle it. So hopefully this error boundary lesson is interesting to you. It's something that was introduced pretty recently with the new React version, and people have been playing around with it as well, and now you are fully equipped to tinker around and play with it to see how you like to use it. Again, both suspense, lazy loading, error boundary, these are all just new tools that React keeps introducing in order for developers to have an easier time by extrapolating away some of the patterns required to handle errors with your components, lazy load your components. It's all just really easy to improve our performance and improve the overall user experience of our React application. So with that, let's move forward with more performance optimizations for our application.